Hello students, so we will do this question today. So the question is define ellipse and derive the equation of ellipse x square upon a square plus y square upon b square equals to 1, a greater than b. Okay, so first of all we will write the definition of ellipse. What is definition of the ellipse? Okay, so let me first write the definition of ellipse. Ellipse, the set of all points in a plane such that the sum of distances from two fixed points always constants. Okay, so this is the definition. Now let me explain the definition for you. Let's assume this whiteboard is your plane. Okay, in the infinite points are there, infinite points like this. Okay, what is the condition? The sum of distances from two fixed points always constant. So what we will do, we will fix 2 points first. Suppose here and here I have fixed 2 points, f1 and f2. Okay, then I will collect from these all the infinite points. We will collect only those points such that whose sum of distance always constant. For example, suppose here 1 point, then this plus this p1, or here 1 point p2, then this distance p1 f plus p1 f2 equals to some constant. Okay, or this point p2, then p2 f1 plus p2 f2 is constant. Or if I can say some other p3 points, we will take only those points which will follow the condition p3 f2 constant. Okay, so if I collect all these points, they will follow one path. Okay, they will follow one path. So if I join all such points, then they will make a curve. That curve will be your ellipse. Okay, so I have explained you the definition of the ellipse in very detail. Okay, what actually is ellipse? Okay, now we will prove the standard equation of the ellipse. Proof next. So in the proof, first of all, we have some construction. Construction means we will make an ellipse. Okay, this is the ellipse, and in the standard ellipse, center is always at the origin. This is suppose y-axis, this is your x-axis. Okay, so to prove the standard equation of the ellipse, we will assume, let f1, okay, two fixed point we will take now. Suppose this is f1, this is f2. These are what? Two fixed points. Let f1 whose coordinate we will take c comma 0, minus c comma 0, and f2 whose coordinate c comma 0 be two fixed points such that origin is the midpoint. Okay, origin is the midpoint. This is the midpoint. All right, this is origin, x-axis, this is y-axis. So here we have taken the coordinate minus c comma 0, and here c comma 0. Also these are the vertices of the ellipse, a and b. We will take, this is a comma 0, and here minus a comma 0, and this is endpoints of minor axis, here 0 comma b and 0 comma minus b. Okay, now suppose on this ellipse there is any point p, general point. So coordinate of general point, we will take p x comma y. So if I join this to this and this to this, okay, f1p and f2p. So by definition, first of all we will let p point is pxy be any point on the ellipse Okay, P is any point on the ellipse. Then by definition of the ellipse, P f1 plus P f2 equals to constant. Okay, so this we have assumed one point, this, so it means P f1 plus P f2, this also constant. But actually in the standard ellipse, that constant equals to 2a. Okay, this constant equals to 2a. Now you must be wondering how it is 2a. Why 2a only? Okay, in the standard equation of the ellipse. So if you want to know why it is 2a, you just let me know in the comment box. I will explain how it is coming 2a. Okay, for now we will take 2a. Next we will apply the distance formula. Coordinate of P we know x comma y, and coordinate of f1 also minus c comma 0 given, and f2 c comma 0. Okay, so what will be P f1 distance by using distance formula? What will be P f1? So P f1 will be root over P f1 x and distance formula x minus plus x plus c whole square plus y minus 0 whole square plus P f2 would be x minus c whole square plus y minus 0 whole square equals to 2a. Okay, now we need to solve this. Okay, so before solving, I will take this quantity on the right hand side to remove the square root. X plus c whole square and y minus 0 is y square only, equals to 2a minus root over x minus c whole square and y minus 0 is y, so it is y square. Okay, now do one thing, squaring on both sides. Okay, SOBS means squaring on both sides. Then square root cancel, then you will get x plus c whole square plus y square equals to, and this is a minus b whole square type, so it will be 2a whole square plus square root x minus c whole square and y square whole square minus 2 into 2a into this x minus c whole square plus y square. Okay, this square root square cancel, so this and this cancel. So what we will get next we will get x plus c whole square plus y square. So at a time open this, so from here you will get x square plus c square plus 2cx plus y square equals to 2a whole square is 4a square plus, and this also open, x square plus c square minus 2 into x into c, 2xc plus y square minus 2 into 2 4a root over x minus c whole square plus y square. Now you can see just x square cancel, c square cancel, y square cancel. Next this 2cx and 2cx, this minus 2cx I can shift on the left hand side, so 2cx and extra 1 2cx, so it means what, this is 4cx now, this is 4cx. Okay, equals to right hand side we have minus this 4a square minus 4a root over x minus c whole square plus y square. Okay, now you can see 4 common and 4 cancel. Okay, so we are getting cx, and this a square we can take left hand side, cx minus a square minus a root over x minus c whole square plus y square. Now this extra square root is there, so to remove square root again we need to squaring on both sides. So again squaring on both sides, so we will get cx minus a square whole square equals to, and minus a whole square, it will be a square and root cancel, so x minus c whole square plus y square, this. Okay, open this, cx minus a square whole square, so it is cx whole square plus a square whole square minus 2 into cx into a square, and it is a square. Open this, x square plus c square minus 2cx y square, so it is c square x square and it is a square square power to power multiply. For 2c x a square equals to, multiply this, a square x square and a square c square minus 2c x a square plus a square y square. Now you can see 2c x a square, 2c x a square cancel. Okay, all right. Now nothing can be cancelled. So now in the standard ellipse, we have a relation between ABC. Okay, what is that relation? Relation is c square equals to a square minus b square. This is the relation in the ABC in the standard ellipse. Oh, if you want to learn the proof of this, just let me know in the comment box. I will do the proof. So here it means c square value is a square minus b square. So put here. So it would be c square means a square minus b square x square plus a power 4 equals to a square x square plus a square, and c square means a square minus b square plus a square y square. Multiply a square x square minus b square x square plus a power 4, and it is a square x square plus a square into square a power 4 minus a square b square plus a square and y square. Now you can see some terms is cancelling. For example, a square x square cancel, b power 4, oh, a power 4 cancel. Correct now? Now this a square b square we can shift here. A square b square equals to, and this b square x square right hand side shift, b square x square plus a square y square. Now divide by a square b square, complete equation. So you will get a square b square upon a square b square equals to b square x square upon a square b square plus a square y square upon a square b square. Now you can see this cancel, b square cancel, a square cancel. So what we getting? We are getting finally x square upon a square plus y square upon b square equals to 1. X square upon a square plus y square upon b square equals to 1. Okay, so this is the proof of the standard equation of the ellipse. Okay, if anything doubt, just let me know in the comment box, I will reply.